That sound you just heard? That's the most expensive sound in the universe. That's the sound of time marching forward, irreversibly, relentlessly, and honestly, kind of rudely. Because here's the thing nobody tells you. The laws of physics, they don't care about time at all. Welcome back to the channel. Today, we're doing something absolutely insane. We're going to try to understand why you can't unscramble an egg, why your coffee always gets cold, and why despite every single law of physics suggesting otherwise, you remember yesterday, but not tomorrow. We're going down the deepest rabbit hole in science. But don't worry, I'm leaving breadcrumbs. Or croutons. Let's go with croutons. Classier. The part that broke my brain. Let's start with the part that broke my brain. If I show you a video of a ball bouncing and play it backward, you can't tell the difference. Seriously. Newton's laws work exactly the same whether time moves forward or backward. Drop a ball, gravity pulls it down. Reverse time, gravity still pulls it down, which is now up. The math doesn't care. Einstein? Same deal. General relativity? Time reversible. Quantum mechanics? Mostly reversible. Electromagnetism? You guessed it, completely reversible. So here's your first existential crisis of the day. At the microscopic level, time has no direction. None. Zero. Zip. The universe is like forward, backward, whatever, dude, I'm just vibing. And yet, here we are, aging, forgetting where we put our keys, watching our rooms get messy and mysteriously, never spontaneously cleaning themselves up. What gives? The entropy deep dive. Enter Ludwig Boltzmann, Austrian physicist, mustache game, legendary. Contribution to humanity, explaining why everything falls apart. Boltzmann gave us the second law of thermodynamics, which sounds boring until you realize it's literally the only law in physics that distinguishes past from future. Here's the deal. Entropy, a measure of disorder, always increases. Always. Your hot coffee gets cold because heat spreads out. Your room gets messy because there are way more ways for your room to be messy than clean. Think of it like this. Imagine you have a deck of cards in perfect order, ace through king, all suits separated. There is exactly one way for that deck to be perfectly ordered, but there are 8.07 times 10 to the 67th ways for it to be shuffled. That's an 8 followed by 67 zeros. To put that in perspective, that's more than the number of atoms in our galaxy. So if you shuffle randomly, what are the odds you'll accidentally get perfect order? Basically, zero. And that's entropy. The universe isn't forbidding your room from cleaning itself, it's just statistically impossible. There are infinitely more ways to be messy than clean. But here's where it gets weird, and I mean question your entire existence weird. The Boltzmann brain paradox. If the universe is just random particles bouncing around, and given infinite time, anything that can happen will happen, then eventually, purely by chance, particles could arrange themselves into a brain, a fully conscious brain complete with false memories of having existed for years, floating in empty space. This is called a Boltzmann brain. And statistically, in an infinite universe, there should be way more Boltzmann brains than actual human brains, which means, statistically, you might be one. Right now. Your memories of childhood? False. This video you're watching? Never happened. You're just a temporary fluctuation in the void hallucinating an entire life. Sleep well tonight. Laughter track, or host chuckling. Okay. Most physicists think Boltzmann brains probably don't actually happen for complicated reasons involving quantum mechanics and the cosmological constant. But the fact that we even have to consider it, that's how deep this rabbit hole goes. The cosmic perspective. But let's zoom out, way out, to the beginning of everything, the Big Bang. The universe starts in an incredibly low entropy state, incredibly ordered, And ever since, entropy has been increasing. That's our arrow of time. Past equals low entropy, future equals high entropy. But why did the universe start ordered? This is literally one of the biggest unsolved problems in physics. Some physicists think it's because of the Big Bang's special conditions. Others think it's related to the multiverse. Maybe most universes start high entropy, but we happen to live in a rare low entropy bubble because otherwise we wouldn't be here to ask the question. That's called the anthropic principle, and it's basically the universe's way of saying, you're welcome for existing. Don't ask too many questions. CP violation, the plot twist. But wait, there's a twist. In the 1960s, physicists discovered something called CP violation. Without getting too technical, certain subatomic particles behave slightly differently than their mirror-image time-reversed counterparts. This was huge. It was the first time we found a physical process that actually distinguishes between past and future at the fundamental level. It explains why the universe has more matter than antimatter. But here's the kicker. CP violation is way too weak to explain the arrow of time. It's like finding a single arrow in a forest full of two-way streets. It exists, but it's not why we age. So we're back to entropy. The psychological arrow. But let's get personal, because there's another arrow of time, the one in your head. We remember the past, but not the future. But here's the wild part. Your brain is also just particles following physical laws. So why does consciousness seem to move forward? Physicist Sean Carroll argues that we remember the past because the past had lower entropy. Our brains are essentially entropy-measuring devices. We form memories by creating correlations in the world, arranging neurons in specific patterns, and that process, it increases entropy. So your memories, they're literally entropy in action. Every time you remember something, you're participating in the universe's slide into disorder. You're not just in time, you're made of time's arrow. The heat death, bringing it home. So where is this all going? In about 10 to the 100th years, that's a 1 followed by 100 zeros, even black holes will evaporate. The universe reaches maximum entropy. Heat death. No temperature differences, no energy gradients. Nothing can happen. No stars, no life, no thoughts. Time stops making sense. But here's the beautiful, terrible truth. We exist in the Goldilocks zone of entropy. Not too ordered, we're not a frozen crystal. Not too chaotic, we're not heat death. We're in that sweet spot where complexity can exist. Stars can burn, planets can form, brains can think. Every time you feel the sun on your face, every time you laugh at a stupid joke, every time you wonder about the universe, you're riding the wave of increasing entropy. You're a temporary complex pattern in a universe that's slowly but surely becoming simpler. And that's kind of magical. So why does time only move forward? Because the universe started ordered and is becoming disordered. Because there are more ways to be messy than clean. Because you're a pattern of particles that can only exist in the space between low entropy and high entropy. The egg can't unscramble because math. You can't remember tomorrow because thermodynamics. And the universe, it's just following the path of least resistance from order to chaos. But here's the thing. While we have time, while entropy is still increasing, we get to ask these questions. We get to be conscious in a universe that, statistically speaking, should be completely unconscious. So maybe, just maybe, the arrow of time isn't a curse. Maybe it's an invitation to think, to wonder, to exist. Now, if you'll excuse me, I'm making an omelet because some forms of entropy, delicious.